The second part of 6.3 is going to look at the period transformations for the sine and cosine functions. So on one period, I want you to sketch the cosine 1/2 t and cosine of 2t. So if we broke it down and said cosine of 1/2 t, it would look like this. So the first thing that we need to identify is what has been done to it. So cosine t has been stretched horizontally. So to figure out the period in this situation, as you can see up top in the box, we have the period, which is equal to 2 pi over the absolute value of our change in the period. So that is, we call that b. So in this case, we have 1/2, which is going to give us 4 pi. So if I were to sketch this graph, I would have my values at 1 and -1. Okay, so that means that I need to go all the way to 4 pi. So if I were to label this, just like I'm used to, I start with pi over 2, pi, I'm sorry, 3 pi over, pi, 3 pi over 2, 2 pi, then we have 5 pi over 2, 3 pi, and then we have 7 pi over 2, and then we have 4 pi. Okay, so graphing this one, let's graph this one in pink. So I have, since it's cosine, I'm going to start at 0, 1. Okay, so since I know one full period is going to be 4 pi, each interval in between that has a point is going to be a quarter of our period. So if you take 4 pi and you divide it by 4, you get pi. So that means every pi is where we have a point. So our next one is pi at 0. Then we have 2 pi comma -1, 3 pi 0, and then we have 4 pi positive 1. So this is our cosine function. So it will look like this. And as you can tell, it is more stretched out than we're used to seeing. Okay, so let's look at 2 pi. So if we graphed cosine of 2 pi, 2t, then we know that, just like we knew from before our transformations, that it's going to be compressed horizontally. So what does this mean? This means the period is going to equal 2 pi, and our b value here is 2. So one full length of our cosine function is going to be from 0 to pi. So we're going to label this one in green. Okay, so if I took pi and I divided it by 4, then that means I'm going to count every pi over 4. So I actually need to add in pi over 4 as a point. Then my next one's going to be pi over 2, and then I need 3 pi over 4, and then pi. So I'm going to end at pi. So it's definitely going to be compressed, and we're going to start at the same value, 0, 1, but now our first one is pi over 4 at 0, and then we're going to have pi over 2 at -1. We're going to have 3 pi over 4 at 0, and then pi is at 1. So my cosine graph looks like this. So this is an example of stretched horizontally and compressed horizontally. And those values, those transformations, stretched and compressed, are from all the function transformations that we had done before. So it's the same even with trig functions. Okay, so number 6, 3 times sine of 2t. So let's copy down what has been done to sine of t. So it's been stretched vertically. And we know that from the 3 in front. And what that means is that we have an amplitude that is going to be equal to 3. And the 2 in front compressed it horizontally. So that means that we need to figure out that our period is equal to 2 pi over that b value, which is 2. So we have pi. Okay, so 2 things being done, stretch vertically and compress horizontally. So the first thing I'm going to do is label my compression for my amplitude. So I'm going to be up at 3 and down at -3. Okay, so then we need to label our intervals. Well, our period goes to pi, so then each interval is going to be a quarter of that. So it's going to be pi over 4 is our first one. And then pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. Add another pi over 4, and we have 3 pi over 4. And then add another one, you have 4 pi over 4, which is pi. Okay, so we know, we're going to graph it in purple. So since it's sine, I'm going to start at 0, 0. And I'm going to go up to pi over 4, comma 3, pi over 2, comma 0, 3 pi over 4, comma -3, and pi, comma 0. So this is my sine function that has been stretched vertically and compressed horizontally. Okay, so now we have -4 sine times 1/4 t. So again, we're going to figure out what has been done to sine of t. So the first thing that it has been done is stretched vertically. And my amplitude, therefore, equals 4. It has been stretched horizontally. Remember, if we have a number less than 1 inside with the t value, it's a stretch for horizontal. So this means that I need to figure out my period. So that's 2 pi over that b value, which is 1 over 4, which is 8 pi. And we can't forget that negative in front. That negative means that it has been reflected vertically. Okay, so again, the first thing that I'm going to graph on my graph is my amplitude up at 4, down at -4. And then I'm going to label my x-axis. So since my period is 8 pi divided by 4 is 2 pi. So that's what we're going to count by. So we're going to have 2 pi, 4 pi, 6 pi, and 8 pi. So it's sine, so we're going to start at 0, 0, but it's been reflected vertically, so we're going to go down first. So we have 2 pi comma -4, 4 pi 0, 6 pi positive 4, and 8 pi 0. So when I connect those, it looks like this. Okay, so this last one, all right, so again, we're going to start with what has been done. It has been stretched vertically because of that 2 in front. Which means that my amplitude is equal to 2. Now, you have to determine, next to t we have 0.4 pi, okay? So pi is a number, so we need to do 0.4 times pi and determine if that is greater than 1 or less than 1. And in your calculator, when you do 0.4 pi, you get approximately 1.257. So what this means is that it has been compressed horizontally and not stretched, all because it's greater than 1. So this means that the period in this case is equal to 2 pi over 0.4 pi. The pi's cancel, and then 2 divided by 0.4 gives you 5. So that is our period. Now, like I said, when we label these, when we label the x-axis, we're going to divide everything by 4. So I'm up at 2, down at -2 for my amplitude. And then each of my axes are going to be 1/4 of 5. So we start with 1/4 of 5, which is 5 divided by 4. So I'll show you what you do each time down here. So 5 divided by 4 is 5 over 4. So then the next one is going to be 5 plus another 5 over 4, which is equal to 10 over 4. But you need to simplify and make that 5 over 2. Okay, so this is our second one. This is our first one. Then I'm going to add another 5 over 4, and I'm going to get 15 over 4. That's my third one. That does not simplify. And then when I add another 5 over 4, I get 20 over 4, which is equal to 5. So you should always, when you add each of your intervals together, that last one, that fourth one, always needs to add to give you the value you found when you did 2 pi over your b value, okay? All right, so since this is cosine, we are going to start at 0 up at 2. Then we're going to go pi over 4, 0. I said pi over 4, I meant 5 over 4. 5 over 2, -2. 15 over 4, 0, and then 5, positive 2. So my graph looks like this. Okay, so now we're going to look at writing the equations based off the graph. So there's 3 transformations we've considered so far. We've changed the amplitude, we've affected the period, so we have a period change, and we've also reflected. So based off of this graph given, the amplitude, which is from the center up to the min and max, so right here, this is your amplitude, okay? And for this graph, it equals 2. So, formally, you can also say that your amplitude equals your max minus your min divided by 2. So algebraically, we get 2 minus negative 2, which gives us 4, and then we divide that by 2, so we get 2. So you can see it on the graph, and you can algebraically solve for it. The next part is finding our b value. So the change in our period is our b value. So we have 2 pi over your period. Well, to do this, we need to figure out what the period is. So when I start at 0 and I graph a full cycle, then I end at 3 pi over 2. So 1 period equals 3 pi over 2. That is the full length. Okay, so back over here, you have 2 pi over 3 pi over 2. And that algebra is 2 pi times the reciprocal, so 2 over 3 pi. Your pi's cancel, and you're left with 4/3. Then the last thing you need to do is check for your vertical reflection. We don't have one. This looks like this is a sine graph since we're starting at 0, 0, and we're going up first, so there is no vertical reflection, which means that our equation is going to be y equals 2, because that's my amplitude, and then we know it's sine, like we just said, of 4/3 t. Okay, so looking at number 10. Same thing. Let's start with amplitude. So amplitude is equal to your max minus your min. So my max is 1/2 minus negative 1/2 divided by 2. And that equals 1/2 plus 1/2, which is 1 over 2, so our amplitude is 1/2. And then you can see that here we have a value of 1/2. Okay, so my b value, so b equals 2 pi over my period. So looking at the graph, starting at the x-axis, it repeats itself at pi over 2. So we're going to have 2 pi divided by pi over 2, which is equal to 2 pi times 2 over pi, and we get 4. Check for vertical reflection. Well, this is a cosine graph because we're starting at 0, 1, or excuse me, 0, our amplitude, so 1/2. And it goes down first, so there is no vertical reflection, meaning that my equation is y equals 1/2, which is my amplitude, times cosine of my b value 4 times t. All right, and my last graph. So, starting with amplitude, we get 3, my max, minus negative 3, which is 6, divided by 2. So my amplitude is 3. my b value. So I get b equals 2 pi over my period, which is at 4. I know the 4 looks a little to the right of the graph, but that is 4. So we have 2 pi divided by 4, which equals pi over 2. Now, since we're starting at one of our mins or maxes, this is the cosine graph, but since we are starting at our min and going up, we have to note that there has been a reflection. Okay, so cosine t has been reflected. So if you make a note of that, you will add it to your equation. So my equation is going to be y equals -3. So there's my reflection, 3 is my amplitude, cosine of pi over 2, which is my b value, times t.